Everybody, welcome back to another video lecture for Chem 107, and this is Unit 4, and in this particular video we're going to be talking about Chapter 32, and Chapter 32 has everything to do with chemical nomenclature, or this word, this is a big word. Chemical nomenclature, that means naming. We're going to be naming compounds here. Okay, now, before I get into the meat of this, I do want to say that chemical naming can be very broad top. There's so many different systems of naming. This is only the tip of the iceberg. But it's a fun tip because it makes a lot of sense, and it kind of puts a bow on some of this stuff dealing with the periodic table. Okay? Now, I feel like I can't do anything without kind of justifying why it's important to learn as a chemist. And this is why it is because, you know, if ethanol had a different name in 17 countries, it would be really hard to communicate and make sure that what compound we're dealing with is the same in each of those countries. So the idea of coming up with one system of naming compounds is important so that we can communicate what we're doing with other chemists across the world. And so we can communicate betterly the chemistry that we have going on there, right? Get it? Betterly communicate, because I don't talk English goodly. So that's a joke. I mean, I do trip over my words, but that was just a joke. Anyways, okay, move on. So, whenever you're naming, there's actually two systems of naming compounds, well, that we're going to talk about. And they're very close to each other, okay? So the first thing, and it's all related to Unit 4 here, is determining if we have an ionic compound or a covalent compound. Okay, if we have an ionic compound, we name it one way. And if we have a covalent compound, we name it a different way. And again, they're very similar, but they're not the same. Okay, so how do we know if we have an ionic compound? Remember, this is a metal and a non-metal, or a large electronegativity difference. How do we know if we have a covalent compound? If we have two non-metals, non-metal and a non-metal, or a very small electronegativity difference. Okay, and there is no difference between names of polar covalent or non-polar covalent. So the idea is you just need to know if it's ionic or if it's covalent. So once you have ionic and covalent, now we can do some naming. And so we're going to start naming the ionic compounds. Okay, and I have this little mnemonic device where we just say element root I. Okay, so if we have a compound like BaCl2, okay, we name the element. That's barium. And what's the root of chlorine? The root is chlor. So we're going to say barium, chlor, and then we're going to add the IDE ending. So the name of this is barium chloride. Okay. What if we have something like NaN3? Okay, this is an ionic compound. It's sodium and nitrogen together. And so Na, what's the name of that element? Sodium. And then N is nitrogen. What's the root of nitrogen? Well, it's nitr. Sounds weird, but that's what it is. And then it's sodium nitride. Okay? And so that's how we name elements that are that's how we name compounds that are ionic. Okay? It's really just kind of knowing the two elements and then making the ending "ide." Now, for covalent compounds, this becomes a little trickier because now, well, actually, I don't even know if it becomes trickier. The reason why it may become trickier is because we need to know these prefixes, okay, from 1 to 10. Because elements are named now with, when they're covalent, using how many of each element there is in the compound. And so why do we do that? Because it turns out that covalent compounds, because they're sharing and they're not stealing electrons, can form in a lot of different combinations. Okay, so for example, if we have nitrogen and oxygen, they're both nonmetals, so we have nitrogen and oxygen. Okay, so we have the two elements. Nitrogen and oxygen can form a compound that's NO, NO2, N2O, N2O4, N2O5, and that's just the tip of the iceberg. So by saying nitrogen oxide, that doesn't tell us which nitrogen oxide we're dealing with. So in order to clarify that, we have to know how many of each element there are, which the formula gives us. For example, this is N2O, two N's and one O, okay, down here for this one. Okay, there's two nitrogens and one oxygen. Okay, and that's represented when we write the formula by these Greek prefixes. Okay, so let's take a minute and actually do some of these names. Okay, so I started, so I'll start with N2O. Okay, N2O. N2O. I don't have a lot of room to write on these slides, so I write all over the place. So I apologize if you're trying to keep up at home. But N2O. So we do prefix. So how many nitrogens are there? There's two. What's the prefix for two? Di. So we're going to do di, and then now name the element. Di what? Dinitrogen. Okay. And now, how many oxygens are there? There's one. So now we put a space, we do a second word. So what is the prefix for one? It's mono. But because we have two O's next to each other, well, you'll see. Okay, so then we do now we do the root-ide, similar to this. Okay, so, well, exactly the same as that. So now, what's the root of oxygen? Ox. And then we add "ide." Now, the only thing that I was going to say, but I waited until the end, is that because if we were to pronounce this mono-oxide, sounds weird. So what we do is we don't pronounce it monoxide. We actually pronounce it monoxide. Okay, like that. So, and then we shove it together as one word. Okay, so if it sounds weird, it's you probably have to get rid of some of those letters because the prefixes shove it together. Okay, so now what else? Let's do another one of these things. Okay, let's do the next one underneath here. N2O4. So N2O4. Okay, so again. Prefix. What's the prefix for two? It's di. So dinitrogen. Okay, prefix element. And now we have a space. Now we do the prefix. What's the prefix for four? Prefix for four is tetra. Okay, so we do tetra. And then the root of oxygen is ox. And then end it with "ide," tetroxide. And now this is another one of those where when you don't put this, it ends up being tetroxide, no A in there. Okay. So now there's one other. There's one other thing. So I had a list here. It was NO. NO2, N2O, N2O4. We name these guys, but let's name these guys, okay? Because there's one special exception that we need to know when we talk about this. Okay, and the special exception has to do with when there is one element at the beginning. So let's look at NO2. Okay, so when it's 1, we would do mono, because that's the prefix for 1, mono, and then element, so prefix element, mono nitrogen, and then prefix, which is 2, that's di, and then oxide. Okay, now the one thing is if the first prefix, if this starts with mono, we don't write it. Okay, we don't include it in the final name. So the name of this compound is nitrogen dioxide. It's assumed that the first element has 1 when there is no prefix indicating how many there are. Okay, so let's try that one more time. Okay, with the last one there. Okay. Okay, so the last one, when we go up top here. So the last one is NO. Okay. Yeah. NO. Again, even though it's not written, I'm always going to write it and then erase it at the end. So that's mono because it's 1. Okay, mono nitrogen. And then here there's 1 oxygen. So then it's monoxide. Okay. So now we look, I already got rid of the O here for mono. It's not mono-oxide, it's monoxide. But then, because this first prefix is mono, now I'm going to get rid of it. So the point is I always do this, and then I go back and check my work. Prefix element, prefix root-ide. So prefix element, prefix root-ide. Okay? And then I get rid of the end. Okay? So that's how we name chemical compounds, both ionic, which is pretty straightforward, and then covalent, which has an extra step in there, but is related to naming ionic compounds. So I hope this helps, and have a great day.